So today we will discuss about the difference between lens and mirror, right? So basically we have two types of mirror and two types of lenses. Okay, let's first see the convex mirror. Basically mirrors are, like we have discussed in a previous video, that lenses are basically transparent, right? They are transparent, but the mirrors are basically opaque. They are opaque. We consider that this is the convex mirror, and it is something like this, right? And this is known as this opaque region, and this is basically reflecting. So reflect. So basically it is opaque. So obviously there will be reflection, and it is known as, like we know the convex lens is basically known as converging lens. So this mirror is basically opposite of it, and it is known as diverging. This diverging, right? So basically the image formed over here is very small in size, and it is virtual, erect, and as well as, like, always it is erect and virtual and small in size. Either it is near the object or it is away from the object. So there will be always small in the image will be always in small in size, right? So next is basically concave mirror, right? Concave mirror. Basically let us discuss here about this is basically concave mirror, and this side is known as reflecting side. This is opaque, and this is reflecting. Basically this concave mirror is converging, right? It will take beam of light and it will basically converge it, right? Okay, basically this concave mirror is opaque. There will be reflection, but there will be converging. It's known as converging mirror, right? The image over here is virtual, erect if it is placed near the image, and the image will be large if the image, like the object, is placed near the mirror. The image formed is basically virtual, erect, and it is large. If the image is placed away, then the image is inverted and real. It is inverted and real. Now let's talk about the convex lens. Basically this is convex lens. Basically it is transparent. So there will be refraction. As well as it is known as converging lens. It converges the light, and basically this is just opposite of the convex mirror. The image over here is virtual, erect, and large if the object is placed basically near, right? But if the image will be inverted, real, if the image is basically if the object is placed away. So it will be inverted, and it will be real, and it will be highly magnified. The image will be highly magnified. Then there is concave lens, right? Right, it is also basically it is transparent, so obviously there will be refraction, and this is transparent, there will be refraction, and it is known as basically diverging lens. It's known as diverging lens, and the image formed over here will be basically virtual, erect, and it will be basically small in size. Always it will be small in size, either the object is placed away or near, right? So I hope this is clear to you. Now let us discuss some basic points of the basic terms of the lens, right? Basically, consider that we are having here a lens. It is basically convex lens. This middle point is known as optical center. This line joining to, like as you can see, they are forming a sphere. The line joining to these hollow spheres is known as principal axis. The middle of the sphere is known as center of curvature, and this point is known as basically pole, right? The distance from curvature to the optical center is known as basically radius. Radius of curvature, or you can see from this to this, it is known as radius of curvature. In the center of curvature and optical center, we have a point known as focal point or principal focus. The distance from focal point to the optical center, is known as the focal length. That is known as focal length, right? Basically, if you want to find the radius, then we have to basically divide the focus point. By 2. Basically, if you want to find the focal length, then you have to divide the radius by 2, so you can easily get the length of this focal length. This is focal length. And if you want to find the radius, then you have to multiply focal length by f, right? If we talk about this now, concave lens, these are two hollow spheres, right? This middle line is known as principal axis, right? This is known as optical center. This is radius of curvature, and optical center distance is basically the radius. This is radius. Now between the center of curvature and optical center, there is principal focus or focus point. The distance between focus point and optical center is basically known as focal length, and if you want to find the focal length, you have to divide radius by 2, right? So I hope this is clear to you, these some basic terms. And one more important thing, this is basically pole, right? In thin lens, the pole and optical center both are same, because the thickness of lens is very thin, so we can't differentiate between the pole and the optical center, so both are same. So I hope this is clear to you. And yeah, one more thing, that this focal length, like conventionally, this focal length for the convex mirror is taken as positive, and for the convex lens and concave lens, like for the convex lens it is taken positive, and for the concave lens basically it is taken as negative, right? So I hope this is clear to you.